In this guide, we'll use the TerraForge library to generate an overworld and then display it as a 2D tile map in Python Tkinter. In order to do this, you'll create the 2D tile map, generate the overworld terrain using TerraForge, add the ability to zoom in and out, add the player to the map, and then allow the player to move on the map. This project lays the foundation for building exploration-based RPGs, simulation games, or sandbox systems in Python. So in order to complete this project, you will need to install or upgrade to TerraForge version 1.3.1 or later, along with its dependencies. So to install the dependencies, you open up command prompt like I have here, and then we'll enter pip install noise numpy pillow. All right, next to install TerraForge, we'll enter pip install TerraForge -core. And if you already have TerraForge and you're just trying to upgrade, you just do pip install TerraForge core -- upgrade. Okay, so this is the starter code for the project. It just creates a full screen Tkinter window as well as imports the TerraForge library for later use. And so if you run the starter code, this is what your screen should look like. We'll start by creating the 2D tile map as a class that inherits from Tkinter's canvas class. So underneath our root, we'll do class tile map canvas. The canvas needs a parent, so we'll make that a parameter inside of the init function. So we define init self parent. The tile map is going to have a thin black border around it, so we'll pass in the highlight background and highlight thickness options into the super init function along with the parent widget. So we'll do super init pass in parent highlight thickness, or we'll do highlight background first. It sets the color of the background, or excuse me, it sets the color of the outline. So the outline is going to be black, and then highlight thickness sets how thick the outline is. So by default, we'll just do 2. All right, so now we'll go ahead and get the tile map up on the screen by initializing it inside of the root class and then displaying it using the pack method. So up here, we'll do self.tile underscore map is equal to tile map self and self.tile underscore map dot pack. We'll set fill equal to both and expand equal to 1. All right, and this is what you should see if you run the code. All right, so the next goal is to get some tiles up on the canvas. So we'll start by defining the minimum and maximum number of tiles we'll allow inside of the tile map class. So down here we'll do self.min underscore tiles is equal to 11, and then self.max underscore tiles is equal to 51. Next, we'll set the starting number of tiles. So we'll do self.map underscore size is equal to 11. Then we'll create an empty list that's going to store all of the tile rectangles. So we'll do self.tiles is equal to an empty list. Now we'll add a method to tile map that's responsible for drawing the tiles. So down here we'll do define draw underscore tiles. Inside of the method, we'll get the canvas width and height. So canvas underscore width is equal to self.winfo underscore width. And then canvas underscore height is equal to self.winfo underscore height. After that, we'll calculate the width and height of each tile. So tile underscore width is equal to canvas underscore width divided by self.map underscore size, and then tile underscore height is equal to canvas underscore height divided by self.map underscore size. So now we'll begin drawing the tiles, but we'll only draw if self.tiles is empty. So we'll do if not self.tiles. Now inside, we'll delete any item on the canvas that has the tag tile. So we'll do self.delete tile. Then we want to iterate through each Y or row in the map and create an empty list to store the rectangles for that row. So we do for SY in range, self.map underscore size, and then row is equal to an empty list. Next, we'll iterate through each X inside of the row. So we'll do for SX in range, self.map underscore size. Now we'll calculate the XY position for the top left corner of the rectangle. So TX is equal to SX times tile underscore width, and then TY is equal to SY times tile underscore height. All right, then we'll draw the rectangle on the canvas using the XY position while calculating the XY position of the bottom right corner. So down here, we'll do rectangle is equal to self.create underscore rectangle. And inside we do TX, TY, that's the coordinates for the top left corner. Then we'll do TX plus tile underscore width, and then TY plus tile underscore height. And those are the coordinates for the bottom right corner. All right, so we'll also tag the rectangle with the string tile and set the rectangle line width to 2. So next we'll do tags is equal to tile, and then width is equal to 2. All right, so now we'll store the rectangle inside of the row list and then store the row list inside of the tiles list. So right here underneath rectangle, we'll do row.append rectangle. And then underneath this first for loop here, we'll do self.tiles.append row. All right, so now we'll add a new method to tile map called update underscore map, which will run every time the tile map needs to be updated. So up here, we just do find update underscore map self, and then inside, oh, one thing we do have to do, we'll do self, and then we'll do event is equal to none. All right, now inside we'll update the canvas widget, so we'll do self dot update underscore idle task. Then we'll call draw underscore tile, so self dot draw underscore tiles. All right, so finally, we want to bind the update map method to a configure event so that every time the canvas changes, update underscore map is automatically called. So we'll just do that right here inside of tile map. So at the bottom here, we'll do self.bind configure, and then comma, and then we're going to call update, or set it to update underscore map. If you run the code, you should see a simple tile map is now drawn onto the canvas. All right, so now we're going to generate an overworld biome map using TerraForge and display it on the tile map. So the first step is to initialize the TerraForge generator inside of the root class. So up here inside the root class, we'll just do self.overworld underscore generator is equal to TerraForge initialized. All right, so TerraForge has a lot of different parameters that you can tweak to generate a map that's to your liking. But to keep things simple in this tutorial, we'll just use the default settings. So if you're interested in those parameters, you can read about them on the library's wiki, which I'll link in the description below. Also for reference, this is what the default map looks like. All right, so since we're using the default parameters, that means you don't have to pass anything into the TerraForge instance. So the next step is to generate the map. So underneath, we'll just do self.overworld underscore generator dot generate underscore noise. Next, we'll go inside of the tile map class and make the generator an attribute so we can easily call it inside of the tile map methods. Since the generator is attached to the root class or parent class, we can just borrow it from there. All right, so inside of the tile map class, up here we'll just do self.overworld underscore generator is equal to parent.overworld underscore generator. Okay, so we already have the code that draws the tile rectangles inside of draw tiles. Now we just need to update the rectangle color to whatever the color is on the generated overworld map. After the if statement inside of draw tiles, we'll get half of the current map size. So down here, we'll just do half is equal to self.map underscore size divided by 2. Next, we need to loop through every tile that's currently visible on screen. So we'll just do for sy in range, self.map underscore size, and then for sx in range, self.map underscore size. Okay. All right, so next we convert the screen tile position into the world position that it should display. So we'll do wx is equal to self.player underscore x minus half plus sx. And then we'll do world y is equal to self.player underscore y minus half plus sy. So before we grab a color, we should make sure the world coordinates are valid. So if the player is near the edge of the world, some visible tiles will be outside of the map bounds. So we'll do if 0 is less than or equal to world x, and if world x is less than self.overworld underscore generator.map underscore size, and if 0 is less than or equal to world y, and if world y is less than self.overworld underscore generator.map underscore size. And then we'll just put pass for right now. Okay, so if the tile is in bounds, we can pass the world coordinates into TerraForge's tile underscore color method to get the correct color for that tile. So we'll get rid of pass and do color is equal to self.overworld underscore generator dot tile underscore color, and then we're going to pass in the world x and world y that we want the correct tile color for. Okay, so if the player is near the edge of the map and the tile that is currently being shown is outside of bounds, we'll just color it black. So we'll put else and do color is equal to black. Okay. So now that we have the correct color, we need to update the correct rectangle on the canvas. So first we calculate where the rectangle should be drawn. So we do tx is equal to sx times tile underscore width, and then ty is equal to sy times tile underscore height. Then we grab the correct rectangle from the self.tiles list. So we do rectangle is equal to self.tiles sy s6. All right, so now we update its position in color. So we do self.coordinates. We want to update the rectangle item, and then we're going to update its coordinates. So we'll do tx, ty, which is the top left corner of the rectangle, and then for the bottom right corner, we do tx plus tile underscore width, and then ty plus tile underscore height. And then we'll do self.item configure rectangle, and then we're going to change its color. So fill is equal to color. All right, so the last thing we have to do is set the default player XY coordinate inside of the tile map class. So we'll go up here and we'll just place the player in the middle of the map. So we'll just do self.player underscore x is equal to self.max underscore tiles divided by 2. And then we'll do the same thing for the y. All right, so when you run the code, you should see just a small section of the overworld map. And if you use the default TerraForge settings, your map should look exactly like this. It should have like a little beach area, a little, I guess like a little grassland area. And I guess we could consider this area a swamp area. So your map should look exactly like this if you use the same settings, or if you passed in no settings at all. All right, so one way to see more of the overworld map is by adding zoom. So inside of the root class, we'll bind the zoom functions to the plus and minus buttons. So up here inside root, we'll do self.bind plus, and then we'll do self.tile_map.zoom in, and then we'll do the same thing for minus, and then we'll do minus, and we'll do zoom out instead. All right, so now we need to create the zoom in and zoom out methods for the tile map class. So we'll go down here, and actually we'll just do it up here. All right, so we'll do define zoom in self event is equal to none. All right, so first we'll subtract the current map size by 2. So we'll do self.map_size minus equal 2. All right, so then we'll make sure that the map size isn't less than the min tiles up here. All right, so we'll do if self.map_size is less than self.min_tiles, then we'll do self.map_size is set to self.min_tiles. Okay. All right, so finally we'll clear out the tiles list and then call update_map. So we'll do self.tiles is equal to an empty list, and then self.update_map. All right, so zoom out is similar, but instead we'll add to the map size. So we do define zoom_out self event is equal to none. Then we'll do self.map_size plus equal to. Then we'll make sure the map size isn't greater than max tile. So we'll do if self.map_size is greater than self.max_tiles. Then we'll do self.map_size is equal to self.max_tiles. All right, so finally we'll clear the tiles list and then update the map. So we'll do self.tiles equal to an empty list, self.update_map. Okay. All right, so now if you run the code, I should be able to hit the minus button to zoom out. As you can see, as we zoom out, we see more of the map. And then now I'm going to hit the plus button to zoom in. So you should be able to do both of those. Okay. All right, so the next step is to draw the player on the map as a circle. So first we'll add a new method to the tile map class called draw_player. And so we'll do it here. Define draw_player. So the player is going to be drawn, or the player circle is going to be drawn in the middle of the center tile. So we need to calculate the tile's width and height. So tile_width is equal to self.winfo_width divided by self.map_size. And then tile_height equal to self.winfo_height divided by self.map_size. All right, so then we're going to make the player circle half the size of the tile. So we're going to do player_scale is equal to 0.5. Now, normally if the tiles aren't perfect squares, it causes the player circle to become more of an oval. So we'll prevent this by either selecting the tile width or the tile height, whichever is the smallest. And then we'll multiply the smallest value by the player scale to get the circle size. So we do size is equal to min, and then we're going to select the smallest between tile_width and then tile_height. Then we are going to multiply that by the player_scale. Okay. All right, so then we'll divide the size by 2 to get the circle's radius. So we do radius is equal to size divided by 2. Next, we need to get the center tile of the map. So we do center is equal to self.map_size divided by 2. So now we need to calculate the middle of the center tile. So we'll do cx is equal to center plus 0.5 times tile underscore width, and then cy is equal to center plus 0.5 times tile underscore height. So before drawing the player circle, we want to make sure one hasn't already been created. So we'll do if not has attributes self player underscore item. So if the player circle hasn't been drawn yet, then we want to draw one. We'll use the center X and center Y to calculate the coordinates for the circle, and we'll just make it red. So inside of here, we'll do self.player underscore item is equal to self.create underscore oval. Then we'll do cx minus r, comma cy minus r, and then we'll do cx plus r, comma cy plus r. All right, and so we'll make the circle red. So we'll do fill is equal to red. All right, so now if a player circle has been created, we just want to update its coordinates instead of redrawing it. So we'll do else self.coordinates. Inside here we'll do self.player underscore item. That is the item that we want to update. Then we'll do cx minus r, comma cy minus r, and then cx plus r, comma cy plus r. All right, so now then we need to raise the player circle to the top layer of the canvas, or it will disappear behind the tiles whenever the map is updated. So we'll do self.tag underscore raise self.player underscore item. Okay. All right, now finally we'll just call draw underscore player inside of the update map method. So underneath draw tiles, we'll just do self.draw underscore player. Okay. All right, if you run the code, you should see a red circle directly in the middle of the map. And I'm gonna zoom out, and as you can see, the circle gets smaller. And as I zoom in, the circle gets bigger. All right, so that's kind of where we are now. Okay, so the very last thing left to do is to add player movement. So we'll start by binding each of the arrow keys inside of the root class. So back up here, let's see, we'll do self.bind left, and then we'll do self.tile underscore map dot move underscore left. Then we'll do right. Then we'll do up. And finally we'll do down. All right, so now we have to go through and add each of the movement methods to the tile map class. And so we'll start with move underscore left. Let's see. All right, so define move underscore left self event is equal to none. All right, so if player underscore x is greater than 0 or not on the left edge of the map, we'll decrease player underscore x by 1 and then move the player left. Then finally we'll update the map. So we'll do if self.player underscore x is greater than 0, self.player underscore x minus equal to 1, and then self.update underscore map. Okay, so I'm just going to copy this and paste. All right. Okay, so we're going to do the same thing with move right by making sure the player underscore x isn't right up against the right edge of the map, and then we'll add 1 to move the player right. So I'm going to change this to right, and then change this to player underscore x, as long as player underscore x is less than self.overworld underscore generator.map underscore size minus 1. Then we'll add 1 to player underscore x, and then we'll update underscore map. And let me make sure I spell right correctly. Okay. All right. All right, so before moving the player up, we have to make sure player underscore y isn't up against the top edge, and then we'll subtract 1. So Again, change this to up. All right, up, and then change this to player underscore y, and as long as player underscore y is greater than 0, then we will subtract player underscore y by 1 and then update the map. Okay, so get this last one here. Finally, we have to make sure that player underscore y isn't up against the bottom edge of the map, and then we add 1 to move the player down. All right, so move down. Player underscore y. So as long as player underscore y is less than self dot overworld underscore generator dot map underscore size -1, we'll add 1 to player underscore y, and then we'll update the map. All right, so one little mistake that I made, this binding code right here, I accidentally put it in tile underscore map. We need to cut this. You see I had it in tile underscore map, and we need to cut that code, and we need to put it up here inside of the root class. And that should be it, and now we're going to run the code. All right, so now we should be able to move. You see I'm moving left, right, up, down. I'm gonna zoom out a bit so we can kind of see what the world looks like. All right, so yeah, so if you run the code, you should be able to move across on the map, and you should be able to hit the boundaries or the edges of the map without moving off the map. Okay? All right, so you now have a procedural overworld map with zoom in player movement. So this is really the foundation that can be expanded into RPGs, simulations, or sandbox style games, whatever you're interested in. All right, so that's it for this video, and thank you for watching.